Okay, so this is the last video we're going to do on AI, and it's optional, really. But I think hopefully it's going to be kind of useful, especially if you have more advanced AI or you're somebody that wants to know a lot more about this. So just as a kind of a recap of where we're at. So we've done 4 videos, I think. So the first, well, this will be the 4th. The first one, we talked about basically AI setup, right? So this was setting up your nav mesh, doing some debugging, understanding the perception component. And then the second and third, we made basic AI controllers. One was a chase, AI that would chase you when it saw you, and then forget about you when it didn't. And then the third one we made, we inherited those properties from the chase controller, but the chase AI, but we also had it patrol. So this AI did a little patrol, and we added some patrol points that it could move around between. Right, and then it would inherit the properties of the chase AI as well. So if it saw a player while it was making its rounds, it would then go off and grab that player or try to grab that player, and then if it lost sight, it would continue to do what it was going to do, right? So go back to its point here and continue to patrol, which is great. But what we want to do now is it wasn't getting too complicated, but it could easily have gone in a direction where it was like many blueprints, or at least quite complex blueprints, and you don't yet know how you may or may not want that AI to behave. So we're going to talk about something called behavior trees. And what they look like, before we jump into one, is they kind of look like, they look like nodes, but they're kind of top to bottom. And so an AI tree could look something like, this. And then we have another one that's off here, or something, right? And so they're top to bottom with an output and an input. So blueprints normally have both either left or right, and they have an input and an output. But the behavior trees, they're top down, and then they're read left to right. So then the AI itself would say traverse a behavior tree. It may get to a condition that's like, if this is set and evaluates true, then it may come down here, and it would then start executing tasks. Task 1, task 2, task 3. Task 1 could be like, start moving towards a player. Task 2 could be, turn towards them, or maybe make a noise. And task 3 could be attack. And these can all be kind of self-contained actions that an AI can take. And what's kind of nice about behavior trees is you can just drag and drop and move them around. So, and maybe over here, if it doesn't see, so say this evaluates to false, and this is not how you would actually, I think we'd have another selector here. This will make sense. But if say this evaluates to false, then we can traverse the tree over here instead, and this may just be a task called wait, and wait for some amount of seconds. That's kind of boring, right? Which is not doing too much, but maybe it could be like, wait for a few seconds and then move to your next patrol point. So you can add much more, kind of more behaviors and some more advanced logic directly within behavior trees, and we'll just call them BTs for now, than you can in blueprints. And so they're a worthwhile thing to wrap your head around. So let's go ahead and go into our engine here, just to remind ourselves where we're at. I think we have our AI, our pathfinding AI, but we took him out. That's right. And I'm going to also remove some of these path nodes. So I'll just hold shift, select this one, delete. They're referencing each other. Yes to all. It's fine. Right. And then I look at next node. It's got nothing. In fact, you go too. So I'm going to take all of those away. So we're going to need another AI controller. that will implement this behavior tree we're going to make. And I don't think we can just, to say, let's take our patrol controller and create a child blueprint class of that. Because if we do, we're gonna get all the chase controller logic that's in its parent. And for this controller, I want to make it a little bit different. I don't want it to chase the player. I want it to run away from the player. So let's create a new blueprint class, AI controller, select, so BP underscore scared controller. So it's scared of the player. And we'll take this same patrol dude and we'll duplicate that because we need to have a character or a pawn. BP underscore scared dude. Okay. I'm going to open this up. Let's see here. You don't have to do this. I am. Scared dude's going to just be smaller, like 25.25 scale. And so he's smaller, and his capsule components then going to be smaller too. Maybe it's like 18. Just trying to get the right thing here. Maybe 12. Fine. 14 it is. Okay, great. And good. I'm going to close that so we don't need it. And then let's drag him over here. Oh, it's so teeny. Can't see it. Okay. Scared dude. Yeah. I'd be scared too if something that large. Okay. Scared dude though, and there's some errors. Oh yes, quite a few. Because what we didn't do, scared dude should be implementing the new controller class that we made, which was the scared controller there. Okay. So if we go ahead and play, nothing's going to happen. Nothing at all. Right. Okay, so we can now go into this AI controller, and we're going to have to do a couple of things here. We know we're going to want to have an AI perception component because we want to be able to perceive when the player is around us. So we know we're going to have that. Let me just dock it there. But we need a couple of new things because we're now going to drive the AI behavior through a behavior tree. And so if we right click here, you go to artificial intelligence, there's these two things, behavior tree and Blackboard. We need one of each. So let's do a behavior tree. I'm going to name it BT underscore scared tree. And we'll do the same thing with a Blackboard. Choose Blackboard BB underscore scared. Fine. Okay. And so just so you know, what a Blackboard is if we open this up, it's going to be a collection of keys and then values that are assigned to those keys and during runtime. So during runtime is important because they're not things we can set as defaults. They'll be set by various activities that are happening within the game. And I know I'm going to need at least this variable, which is a Boolean, that we can say can see player. And can see player means it's something that we want to set to true if our AI can see the player and false if they cannot see the player. So we definitely know we need that. Another thing I think we need is we need a place for the AI to run to, or at least to move to when it does see the player. And that place would be a vector. So let's name that hiding spot. Hiding spot. And so for now, I think that'll be good for our Blackboard. And you can add many, many, many different types of variables. Well, not many, but enough that it can give you quite a lot of flexibility. Okay. So we have that set up. We also need to have our controller implement both the Blackboard and this behavior tree. And so if we go open our controller, go to event graph, off begin play, we want to do a couple things. So one is called run. If we type behavior, run behavior tree. And then we need to select the behavior tree here. In this case, it's this one that we made, BT scared tree. And we also need to use Blackboard. And we want to say we want to use this Blackboard here. And why we do this? Well, if we don't run the behavior tree, then the AI is not going to know to run the different types of actions that we're going to build in the tree in a second. And if we don't have use Blackboard selected, then we have no way to update the, well, it's very difficult for us, if not impossible, to update the Blackboard values that we already made here. And we made 2 of those, the can see player and then hiding spot. And we definitely know that we need to grab some perception here too. So let's go ahead and AI perception and on perception updated and add let's get that out of the way. Add this event here. And so when we get perception updated, let's try this. Right click, get Blackboard. There's a function here called get Blackboard. And what this function will do is we'll get the Blackboard, and we have that assigned here as this scared Blackboard. And then we can set the value. And so set value as. And there's all of these different value types we can set. So the one that we had selected was a Boolean. And so this is how you set and get values that exist in the Blackboard that we made, is you just choose get Blackboard, and then you set that value. So it needs a target, which is its Blackboard. It also needs a key name. And the key name is can see player. And so and it's looking for a name. So if we right click out in space and we say, I think it's make literal name. Make literal name literally lets you make a name. And so we want to make a name. The name should be the same. Can see player. And then that is the key that we will pass in. And the Boolean is true. Okay. So that will mean that we can see the player. But it's not completely, this is not going to work all the time. Because as we know, our AI perception is firing off anytime there's some perception event. Oh, and by the way, what we forgot to do in our AI perception is we need to add a sense to it. So go to senses config, sense of sight, expand this out, and I think we had something like 800, and maybe we'll make it, he's very scared all the time. Let's do 500 and 550, and peripheral vision is 90 is fine for now. Okay, and the other thing we need to do is make sure that we're detecting neutrals. That happens to be the player, how the player will be detected here. Okay, so I want to stop here in the AI controller and actually go to the behavior tree here. And so when we open up the behavior tree, this looks a little bit similar to Blueprints, kind of. There's this root node, and the root node is just every single behavior tree will have a root node, and there's not actually anything it can do other than just be the thing that when you have it selected allows you to select your Blackboard asset that you're going to use. But because we only have one Blackboard asset, that will automatically assign here. We want to make sure save there. So anyway, it's assigned here, and then we can see our keys down here on the right hand side. So what do we want to do? Well, if you drag off of the output here, you can place a new node. And the first type of node, there's really two types. One is tasks and the other is composites. When you first drag off, you need to drag off a composite node. And there's 2 of them that are important. And the third one that actually is not as useful or as important. So the selector or the sequence. So the difference here is that if you say you have a sequence node is going to, well, you mouse over, you'll see, it's going to execute any of the children that it has from left to right, and then it stops if one of the children fails. And if a child fails, the sequence fails, and that's it. So it's not, that's a sequence. And so you can have different tasks here, and maybe you have one that's like, move to, since we already have hiding spot, it thinks move to hiding spot. And then maybe another task could be, play a sound, and we might have a sound that we want to assign to this. And then it doesn't sound great. You're making all this noise as you're moving. And then maybe rotate to face the enemy, right? And then we would test this and be like, oh, that's not the right thing. We want them to move and then rotate, then play the sound. Well, you can drag these and place them in a different order, and you'll notice that this 1, 2, 3 will update accordingly as you move it around. So as you get used to working with behavior trees, this functionality right here, the functionality of being able to say, it looks like they should have done that thing, and then that thing, and then that thing instead, enables you to move really, really quick, especially when you're prototyping AI. And so that's a sequence. The other type is a selector. And what a selector does is it's going to execute children from left to right, but it stops when one of the children succeeds, right? So this is going to select from left to right a condition, and then if that condition is true, then it'll execute things. So mainly one of the ways this is used in AI is you'll put a selector here at the top, and then you'll have another sequence of events, right? And this sequence of events will have within it something called a decorator. And that decorator is just a conditional statement. So it's some type of condition generally, checking if something's true or false, or running some type of function to get an output that's 1 or 0. And if that evaluates to true, then you would have your different tasks. Like you might have something like move to, and then rotate. And you can make your own tasks too. These happen to be like high frequency tasks here. Then rotate, and then maybe you have, and they don't have one that's an attack, but you could build one, and then maybe you play a sound, and then or something like that. And then you would have another sequence of things off here that was your, like maybe you'd move to, instead of hiding spot, it could be just your patrol location. And then you might just decide you want to wait for 5 seconds. And so that this would look like in practice, if that's kind of the way that we had set up our behavior tree, is many times a second. It would run the root node, it would go to this selector, and the selector would then check the decorator, it's called, but check something that we had maybe programmed in to see, this is what we want to do, this is a particular condition. In fact, let me right click and just add a Blackboard decorator. And a Blackboard decorator will look at a Blackboard variable, and based on the condition of that key, if it evaluates to true, it will run it. And in this case, it said I only had one Boolean, so can see player. So it kind of was smart enough to know that, well, that's all you have. So that's the thing I'm going to check. Can see player, right? Can see player is set, meaning it's true. Then move to maybe the player instead of the hiding spot, and then rotate to face the player, and then play a sound if that sound had been there. If this condition evaluates to false, then the selector will evaluate this sequence to true, because there's nothing sitting on here that says that it should be otherwise. And if this doesn't make sense, let's actually try to show you some way of debugging these. So what I'm doing now, I dragged off this behavior tree, and so I kind of have a little bit of a halvesies going on here. I want you to be able to see this visually as I play. And then we should just be able to go to simulate. And so simulate. Yeah, so that flashing here, and you see the little flashing red, that means it's evaluating to false. This particular condition. And if you look in the lower right, this is always false. Can see player is false. And because that is evaluating to false, then it's never hitting these nodes here below. It's only hitting this move to node. And that move to node is also invalid. So there's no place, hiding spot is an invalid node. It's not being set. And so this whole behavior tree is just boo-how, doesn't work. But it gives you an example of like how the selector node, the selector, the composite node here and the sequence composite node can kind of work together. And you can put these together to make really complex types of AI behaviors. Almost anything you can think of. So, like just to give you an example, if we were to delete that move to node and simulate it, then it's just gonna, sit here on the wait node for 5 seconds. And if we select over here, if we select our, since we have AI debug on and we select our little scaredy guy here, in his AI category, we can see what he's doing now. So controller name, the pawn name, the movement mode, now data behavior is running. He's running this scared tree, which is what we named up here. And here's his active task. It's wait. It's always going to be wait. And that's it. Nothing too interesting, but he is running his tree. And you will see, if your eyesight's really good, you're going to see the selector fire off to this blackboard-based condition every 5 seconds. But it'll do it like really, really fast. Like it'll just go click, and it'll evaluate to false. You saw it there. So the root node ran, and then it evaluated to false. All right. So that's a quick, super fast kind of introduction to like behavior trees. But this is not the behavior that we want. The behavior that we want is, in my mind, I want it to move to hiding spot. I do want it to move to a hiding spot. So actually, I'm going to keep that. So this is, and I want the option of maybe it doing other things later on. So I do kind of want it to say, okay, if you can see the player, move to the hiding spot. Otherwise, just chill. And then again, this sequence could be otherwise, maybe later you go, you move around, you go shopping or something, whatever you want to have happen. It's not a bad framework for us to start because we can set some of these values. And the values that we want to set, so the first one we want is we want to be able to set the value in our Blackboard that can see player value. So we can close our Blackboard here. Let's save it and close it, and then go back to our scared controller. So this is that first thing we had done, can see player. We started to kind of do this because we knew that that's what we wanted when it was updating perception. But we also know that this on perception updated event is going to fire every time perception is updated. And like the last time we made this kind of complicated, well, let's look at it, kind of complicated chase controller. We had done this thing like here. It's like on perception updated. We got the first one. Then we like got the actor's perception. We broke the perception, and we got this successfully sensed, and we had this branch, and it was like, I see you, and then you move, and I don't, and then we lose stuff. You can go ahead and recreate that, and you can copy paste it in, and then have that logic, and then instead of moving to an actor, you're just going to set the Blackboard value, the Blackboard values that you want. That's one way to do it. The other way, though, I feel like I want to introduce you to another useful blueprint node. And this blueprint node is called the flip-flop. So flip-flop alternates between A and B outputs starting with A. So it will alternate. So every time it's called, it will so if you call it one time, it will go with A. You call it a second time, it will go with B. And then vice versa. It just kind of flip-flops between those two variables. And that's kind of exactly what I want based on what I know to be the case with this perception component. I know that it will update only because we only have sight. It's going to update. It's going to basically the first time is going to be I see the player or whatever it is I'm looking at what I want to see, right? Whether it's player or another AI or something. And then the second time that's updated, it's like I don't see it. At least in our case. If there's more than one player or if there's more than one AI, then this flip-flop node will produce unexpected results because it will flip-flop every single time that perception is updated. And sometimes perception is being updated with a successfully sensed event, and others it's an unsuccessful event. So if you want to be kind of perfect about this, we would take the AI chase controller logic where we do get a successfully sensed event in, and then we would say, okay, now you're successfully sensing something, do this thing, right? Run away, and vice versa. So, but for now, just because the point of this, I think, is more to say, here's behavior trees, here's how you can use them. We can just do this, and then we'll probably laugh at the result. So doing this means we just want to flip-flop the value of the Boolean as well. So we need to set it to, so setting the can-see player to false. So we set it to true, and then the next sense event, we're going to set it to false, and vice versa every single time. So let's play that. Okay, so that's the can see the player, and so if we play this again, I want to have my tree open, so I want to do a little bit of debugging of values. What do we expect to happen? So if I go ahead and I choose to play, in the lower right you see can see player is false. So if I move in, yeah, you see now can see player is true. And so now that can see player is true, we have this getting evaluated here. Although you see it's still hitting this weight. That's because we have an invalid hiding spot. So this whole sequence is failing, because if a child fails, the sequence fails. So the sequence is failing because move to is failing. All right, so now we need to set the move to. So move to hiding spot. So what we'll do in this case is, I think we can do, I'd like to actually, yeah, so I want to show you another, basically, like we could set move to hiding spot within, we could set that hiding spot, here, let's drag this in. We could set the hiding spot here if we wanted to, or we could set it in event tick. But since this is all about behavior trees, I want to show you how we could set this directly in the behavior tree itself. So we want to use something called a selector. So if we right click on the task, so a decorator is this blue thing here. We added one that just comes with it comes with behavior trees called Blackboard. So this is a Blackboard based conditional. And for services, we go service, you don't see as many things as you do with decorator, right? So we'll need to make a service. And the service we want to make is going to be pretty simple. So you can click new service here. And if you click new service, it will open up a new service, and it gives it this huge name, BP service, blueprint base, new. And it puts it in that folder, and it's super long. So let's just take this and right click and rename it to BP underscore random hiding spot. I'm going to do a random hiding spot. Okay. So now it's random hiding spot. So we can open this. And so all I want to do, I think in this particular case, is I'm going to simulate it running away. Actually having it find a good hiding spot and then move to that hiding spot would probably need us to do something called use EQS, which is the environmental query system, which is a whole nother layer of advanced AI, which gets, I mean, it's super cool, but it's also something that would need another couple more videos just to describe, and then would be many hours into this. So in this case, let's just focus on this service. So we have this service here, it's called random hiding spot. And what do we want to do? So at the time that this task, so we're going to attach the service to this task. So I can do that now. And so this is kind of what it looks like. So this is the service that will run with that task. And we want this service to set the key. We want this service to set the hiding spot key. So think of it like it's just going to be a self-contained, almost like a self-contained blueprint that does what we need to do, and it's clearly its only task is it's going to set this hiding spot key. So we want to right click, and I think it's event activation AI. And so this is what gets called, they should really include, like, again, how they do in the blueprints with these little grayed out stuff, so it's easier for you to kind of remember. But event receive activation AI is just the event that gets called when this task gets run. It's activation. And the controlled pawn has, well, so at the end we definitely know we want to set the blackboard value. So I'm just going to type set blackboard value as vector. Okay. And then the key is different. So the key that we had here was a name key. Here, the key is not a name key. It's a Blackboard key selector structure. And so the best way to get at that is to right click on it, choose promote to variable, and then you want to name the variable name the same name as your key. So in our case, it's hiding spot. Let's make sure it is hiding spot. Yes, hiding spot, and then be sure and make that public. And if we make it public and compile, then you'll see it here. It'll show up underneath your selector here, hiding spot, none. If it's not public, and let's try this, it doesn't show up here. And so you know, if you want to make sure that you see your variable of interest being returned here or being set from the service. Okay, so we kind of want to do that. And so at the simplest value, if we knew the vector that we wanted this thing to hide in, like the x and y of the hiding spot, then wonderful. Or you could even do something similar where, if you remember what we did with our patrol points, you could, you know, do a whole, like, you know, for each, you know, and then do a for each loop and have an array of all those points coming in, and choose one that was far away. You could do a check based on the distance to the player and stuff. But I think in our case, what I want to do is the controlled pawn is the controlled pawn that the AI is controlling. And I'm going to type nav. Yes, okay. Get nav agent location? No. Can we do that? We can. So what I want to do is I want to see where it's at, the navigation agent itself, because that agent is the one that knows the navigation of our entire level here. And then I'm just going to type random. Yes, okay. I love this one. So this get random point navigable radius, or get random reachable point in radius. And so what this will do is this is going to allow us to put in a radius, let's say like 500. And then it will pick a random point and return it. And that's the random point that we're going to set as our value for the vector here. And so now if we run this, what should happen is when you see the player, it will move to hiding spot, and hiding spot is being set by this service that we just created called random hiding spot. And that service that we created takes gets the nav agent location that's on the AI pawn, calls this random point in navigable radius function, and then sets that as our hiding spot vector to move to. So it's not really like it should be called like get random spot, because it's not like always going to run away from the player. But it may appear that it's definitely going to go not towards the player. Most of the time it's going to go in some random direction. So I think we've done enough to play this. So come around here. There it is right there. If we see it, it should just start freaking out. Yeah, yes, there it goes. Runs there, and it sees us. And it should go to another place, yeah. But it's like not moving so fast. Why? I mean, it does eventually. But let's call up our, here, let's again do a little debugging here. I'm going to zoom out with our blueprint tree here. Yes, and then I'm going to play. Okay, so right now it's, you know, evaluating to false, so it's running the sequence that has our wait, our 5-second wait, and then there, boom, it runs, and then it's sitting here on the wait cycle here, and then it sees us. If it sees us when it switches, it'll move. See, and then it finishes and it goes back to wait, and then it's kind of stuck in that wait. So it's not leaving that wait statement. So it's basically what you do, and we won't do it in this video, but just I want to describe this to you, is if you have that situation, you also want to add a condition or a decorator that's checking if you, it's also checking that can see the player, because it will cause this sequence to fail when it can see the player. And meaning fail means like the second that one of those decorators fails, it will stop this wait from executing, even if it's in the middle of the wait cycle, so it will immediately switch over. Otherwise, what's happening is it's just waiting until it gets a chance every 5 seconds to run this again. So for us, we're going to just delete that wait and save it. And now we kind of have no other thing to do but run directly down through this. And so if we play it, we don't need to have it there. We should get a very wild, yeah, it's just gonna, as long as it sees us, it's just gonna start moving, right? Oh, oops. Okay, the last thing I want to do, just for fun, is I think I'm gonna add, it's AI perception, this 90-degree peripheral vision. I'm gonna put it to 180, so it's very aware. And maybe one of the things you could do is, instead of using sight, you might want to use like hearing or something. So it's like like it could be like a bug or something, and you get kind of close to it, and then it's just gonna scatter. And let's see what actually happens if I. So now it has a 360-degree vision. It's gonna see me all the time, always, and just start kind of randomly running away. And it's kind of cool because even the random movement forces me to kind of chase it. So like, I could have spent a lot of time, doing some vector math and getting a point, in the world that I think it should run to. But, this already feels like it's running away from me a lot. Okay, and just to wrap up this video, just again, to have something kind of fun, I'm going to take this, I'm just going to hold Alt and like make a small armada of them, because they're not just going to get triggered from a player, they're going to get triggered from each other also, I think. So if we play this, they're just going to be forever running around like they're just scared. They're scared of everything. And I think you can see already, like these two guys, well, they were having some trouble, but now looks like they broke up. So sometimes they get stuck here, and then I think they'll figure out, okay, that's how I get away from this. And their colliders are getting stuck, I think. But it still looks like it's pretty cool. I know I said this was you can stop this video now, because all I'm going to do, I'm just telling you, I'm going to copy paste like a ton of them and just see what happens. Okay. At some point it's like just too much. Okay, let's play. Frame rates are still good. I mean, yeah, so there's this AI behavior where they crunch together, and I think they have a hard time getting around each other. Yeah, so they kind of, yeah, so maybe having too many of them, that's something we may want to work around. Yay, very cool. Okay, so that's behavior trees kind of in a nutshell. There's a lot more that you can do with it. The documentation that's out there on the Unreal Engine site is pretty good. It's something that they're continuing to work on, so this is definitely more of an advanced topic. Oh wow, they just pushed me. All right, so hope that was fun and you learned something. See you soon.